Welcome to this explainer. Okay, let's dive right into a massive cosmic mystery surrounding a bizarre, suspect lurking in our night sky. When we look up, the Milky Way feels like this static, peaceful, native home, right? But the universe actually has an incredibly violent past. Today, we're going to look at the fingerprints left behind by literally one of the most spectacular collisions in our entire galaxy's history.
We're treating this like a true interstellar crime scene. Our investigation starts with a fundamental question, one that pretty much challenges everything we know about the Milky Way. What if some of the most familiar objects in our local universe don't actually belong here?
Let's establish our suspect. The object in question is Caldwell 73, also known to astronomers as NGC 1851. It's a massive globular cluster located exactly 39,500 light-years away from us, just sitting quietly out there in the Columba constellation. Now, it was discovered way back in 1826 by James Dunlop, and for a long time it just looked like a normal, albeit really bright, collection of stars. But as our technology has improved, wow, Caldwell 73 has revealed itself to be anything but normal.
Section 1. A bizarre stellar population. To understand this macro-scale galactic collision, we first have to look at the atomic anomalies hidden right inside this cluster's core.
So, for decades, globular clusters were considered the simplest stellar populations in the universe. The general rule of thumb was that all the stars in a single globular cluster formed at the exact same time, from the exact same cloud of gas, and with the exact same chemical makeup. Simple, right? But Caldwell 73 completely breaks all the rules. We have a major anomaly here. There are two completely distinct generations of stars living under one roof.
When astronomers mapped the stars burning helium in their cores, a phase known as the horizontal branch, they saw a really clear split. Ultraviolet imaging telescope photometry proves we have two conflicting groups, the red and the blue horizontal branch stars. They don't just blend perfectly, they are completely, undeniably divided. And it's not just their colors or brightness that are different. Spectroscopy reveals wildly different heavy element variations between these two populations. We're talking about huge variations in nitrogen, sodium, iron, and what are known as S-process elements. These are basically heavy metals forged in the slow deaths of older stars. One group of stars is really rich in these heavier elements, and the other is poor. This is a chemical fingerprint that points to highly unusual birth conditions. A simple single cloud of gas just cannot produce this kind of chemical split. No way.
But the most staggering piece of evidence here is a massive 2 billion-year age gap between these stars. The data suggests the blue horizontal branch stars are ancient, forming around 12 billion years ago, while the red horizontal branch stars formed roughly 10 billion years ago. This proves, without a doubt, that they couldn't have formed in a single, simple cluster event. Something happened to this cluster to trigger a second wave of star formation, or maybe it swallowed another cluster entirely.
Section 2. The extended halo clue. We've seen the microscopic chemical clues, so now let's zoom out and look at the structure holding them all together.
Recent deep imaging surveys have revealed that Caldwell 73 isn't just a tight little ball of stars. It's actually embedded in a vast, diffuse stellar envelope, a halo extending over 250 parsecs. That's roughly 800 light-years beyond its normal boundaries. And here's the real kicker. The stars in this massive, diffuse halo share the exact same strange chemical signatures as the stars deep inside the cluster. They are undeniably bound to Caldwell 73.
But here is where the physics just do not add up. Caldwell 73 is on a wild, highly eccentric orbit. It repeatedly plunges right through the dense disk of the Milky Way. Normally, the gravitational shock of smashing through our galaxy's disk would strip away a delicate outer halo like this in no time flat. This halo simply shouldn't survive the cluster's violent trips through the Milky Way. This strongly hints that Caldwell 73 isn't just a cluster at all, but rather the deeply bound stripped nucleus of a former dwarf galaxy.
Section 3. The Gaia sausage merger. It's time to zoom out to the cosmic scale, where all these bizarre clues suddenly make perfect sense.
Here's the plot twist you've been waiting for. Caldwell 73 is an alien remnant. Yep, it was born entirely outside of our home galaxy. The reason it doesn't look or act like a normal Milky Way globular cluster is because it simply isn't one.
And this perfectly illustrates our culprit, the Gaia sausage. This was a massive, ancient dwarf galaxy, weighing in at an estimated 50 billion solar masses. Billions of years ago, it violently collided with the Milky Way on a plunging orbit. As the Milky Way's gravity literally tore this dwarf galaxy apart, it deposited its own native globular clusters into our halo.
and Caldwell 73 was one of them. It's called the sausage, by the way, because of the highly elongated, sausage-like shape its leftover debris makes when astronomers plot it out in velocity space. There are some undeniable physical fingerprints linking our suspect to this ancient collision. Astronomers have identified specific traits for these sausage clusters. Caldwell 73 has an extreme orbital eccentricity of 0.91. That means its orbit is incredibly stretched out, essentially falling straight into the galactic center and slingshotting right back out. It also has energy levels way above the critical threshold that separates native clusters from accreted ones. Plus, it follows an age metallicity track that just screams extragalactic origin, and it clumps perfectly with other sausage clusters in what physicists call action space.
The hard data backs this up beautifully. Just look at those extreme eccentric orbits on the left. See how stretched out those paths are? Totally unlike the calm, circular orbits of native clusters. And on the right, checking out the age metallicity track, the red circles, which include Caldwell 73, follow a completely distinct evolutionary path compared to the gray dots representing the bulk of the Milky Way's native clusters. They grew up in a totally different neighborhood, and the data absolutely proves it.
Section 4. Strong like cosmic beads. Examining how this alien invader actually moves today is kind of the final nail in the coffin.
Astronomers use something called action space to map out orbits. It's basically a way of looking at motion that stays constant even as a galaxy changes over billions of years. In this action space map, Caldwell 73 and about 7 other sausage clusters are tightly clumped together. They have massive radial action, meaning they plunge in and out, and very low vertical action, meaning they don't bounce up and down much. They're strung out together on these plunging trajectories, almost like beads on a cosmic chain, still maintaining the ghost of the trajectory of the dwarf galaxy that originally brought them here.
What this really highlights is the stark contrast between our native, well-behaved circular clusters and these high-energy alien remnants. Native, in situ clusters sit comfortably in the disk or bulge with low energy. Accreted clusters like Caldwell 73 scream their alien origin through their extreme, high-energy plunging orbits. They are, quite literally, the survivors of a cosmic shipwreck.
Section 5. An alien nucleus revealed. Okay. We've looked at the chemistry, the structure, and the orbital physics. Now let's reconstruct the event. This step-by-step reconstruction explains absolutely every anomaly we've discussed today. First, an ancient dwarf galaxy forms. Because it's a whole galaxy, it has enough mass to hold onto its gas and form multiple generations of stars, which perfectly explains our 2 billion-year age gap and weird chemistry. Second, it collides with the Milky Way on a plunging orbit. Third, its outer layers are brutally stripped away by our galaxy's tidal forces, leaving only the diffuse halo we see today. Finally, the dense, heavily armored core survives, masquerading as the Caldwell 73 cluster we see in the Colombo constellation right now. As we wrap up this explainer, I want to leave you with this haunting thought. When you look up at the night sky, you aren't just looking at the Milky Way. You're looking at a cosmic graveyard built on ancient, violent collisions. Caldwell 73 is just one alien survivor hiding in plain sight. It really makes you wonder how many other quote-unquote native stars shining above us right now are actually the ghosts of devoured galaxies. Keep looking up and stay curious.